Okay, here we go with lesson 10, more about graphs. Okay, first things we got to know is any coordinate pair, x, y, that makes an equation or inequality true lies on that graph. Also, the entire graph is going to be a collection of all of the xy pairs that make the equation or inequality true. Making it true is really the important part here to remember. True means when it says something's equal or greater than or less than, then that it has to hold true. It can't be a false statement. All right, so let's take a look. Consider the function f of x equals 2x plus 5. It says, does the point 2, 9 lie on the graph of this equation? And justify our answer. Okay, a couple things here. First, remember that any point is really just x, y. Also, remember that this function notation f of x really means y equals, if you wanted to write it that way, 2x plus 5. So all I need to do to see if that point lies on this graph is plug in those values for the x and the y. So I'm going to put a 2 in for the x and a 9 in for the y. So I'm going to have 9 equals 2 times 2 plus 5. That tells me 9 equals 4 plus 5, which tells me 9 equals 9. And that is a true statement. 9 does equal 9. Let's try it for this other point. Does the point negative 1, 4 lie on this graph? And to justify, I guess we just did justify by checking. Okay, let's see if it lies on the graph by by checking again. So again, here's my x and my y. I'm going to plug these values in. So my y value is 4. So 4 equals 2 times negative 1 plus 5. So that says 4 equals 2 times negative 1 is negative 2 plus 5. And that says 4 equals 3. That is not true. So the answer would be no, and the justification would be 4 does not equal 3. Here I guess you might want to say yes, because 9 equals 9. Okay, so justifying is just showing your work, and make sure you just answer the question. But so what does this mean? That means that that point lies on that line. It makes it true, therefore it is part of the solution in that graph. Let's look at the points on graphs of inequalities. We haven't done a lot with graphing inequalities yet, but we will very soon. So this is kind of just, we don't need to really know or understand what the graphs look like in order for us to check and see if these points work. So again, all we're going to do is we're going to take and we're going to stick these points in and see if it makes it true. Okay, remember that's x and y. So we just have to see if it's a true statement in the end. So my y is 4. 4 is greater than my x is 2, so 2 times 2 plus 1. So that says 4 is greater than 2 times 2 is 4 plus 1. So 4 is greater than 5. And that just sounds weird coming off my tongue. 4 is not greater than 5. That is not a true statement, which means this point does not lie on the graph of this inequality. So no. Let's try the one over in the top right over there. So the point is 1, 5, and we're looking for x plus y is greater than 4. So again, this is my x, this is my y. So x is 1, y is 5. 1 plus 5 is greater than 4. That tells me 6 is greater than 4. And that is a true statement. So this point, 1, 5, does lie on the graph of that inequality. Again, that's what a true statement means, if it's correct in the end, if it sounds right. Let's try this bottom one. Negative 1, 1 is our point, and the inequality is y is less than or equal to 4x plus 5. So let's plug in some numbers. Again, my x and my y. So y is 1, so 1 is less than or equal to 4 times negative 1 plus 5. So negative 1 times 4, well, I have 1 is less than or equal to, negative 1 times 4 is negative 4 plus 5. Negative 4 plus 5 is 1, so 1 is less than or equal to 1. And that is a true statement because 1 certainly is equal to itself. So the answer here is yes, that point lies on the graph of that inequality. So it's exactly the same as we were doing with equations, okay? But these are inequalities. You just plug in the point and check and see if it's true. That's all you gotta do. Not too bad. So let's see what the solution to systems of equations and inequalities would be like. All right, so the solution set to a system is the collection of all points, so everything, that results in all of the equations or inequalities being true. In other words, whatever point I choose needs to work in all of the different equations or inequalities that we have. In this case, we have we have one inequality here, and we have one equation here. All right, and there's a fraction bar there. It's a little hard to see right here. Okay, so we want to see if the point -2, 5 is a solution to that given system. Okay, whenever you see this word system, it's because we have multiple equations or inequalities that we have to deal with. That makes it become a system. That's what we call it in math. So let's try it. All we're going to do is the same thing, but in order for this to be a solution to this system, it needs to work in both. If it only works in one or doesn't work in any of them, it is not going to be a solution to the system. So let's start with that first one. I'm going to separate it and write it over here. Y is greater than 4 minus x over 2. And here's my point, x comma y. So it says 5 is greater than 4 minus -2 divided by 2. Well, minus a negative is add a positive. So that tells me 5 is greater than 6 over 2. And 6 divided by 2 is 3. So 5 is greater than 3. And that's a true statement. So far, we're on the right track. So this first one, it worked. Now we just have to make sure it works in the second one to make sure it is a solution to the system. If it doesn't, then it's just simply not. Okay? So let's try it. Let's take that point, -2, 5. First I'm going to rewrite it over here. Y equals 3x plus 11. I'm going to stick in the -2 for x and the 5 for y. So 5 equals 3 times -2 plus 11. So let's see. 5 equals 3 times -2 is -6 plus 11. And -6 plus 11 is 5. So 5 equals 5. And that is true. So this is true also at that point. And therefore, -2, 5 is a solution to this system because it worked in both. If it happened to only work in one of them, then it would not have been a solution to the system. So the answer here is yes. -2, 5 is a solution to the system. Okay, and that's really all we have for today. We're just taking points and plugging them into equations and inequalities and making sure they are true. Some important vocab was the word system. And we also want to make sure that we understand what a solution to a system looks like. It's when a point works in both or all of the equations or inequalities that are present. All right, that's it. I will see you guys next class. Later.